So today we are going to talk about linear differential equation. We already talk separable differential equation, and then we talk homogeneous differential equation. Now we are going to see the solution of linear differential equation. And here the linear term represent the power is 1, and where both the power of derivative and the variable should be 1. So let us write dy by dx plus pxy equals to qx. It is the general form of linear differential equation where px may be a constant or a function of x, and qx is also be a constant or be a function of x. And if we want to solve this function, then we have to integrate e to the power px dx integration, exponential of px dx integration, and it is known as integrating factor. Okay, so let us multiply this integrating factor on this equation. Then we see e px dx into dy by dx plus px y e to the power vx dx exponential of px dx integration equals to qx power px dx. Okay, so we have to rearrange a little bit of this part, then we can get dy by dx of e to the power px dx integration into y equals to qx e to the power integration of px dx. Okay, you can see that if we apply a chain rule of derivative, then derivative of this and this becomes constant, and further this becomes constant, and derivative of this, when derivative of this, then p comes out, and this derivative is exactly equals to this value. So after rearranging it, we integrate both sides with respect to dx. Then if we integrate both sides with respect to x, then what we will get, then it becomes e p dx into y equals to qx e to the power exponential of p dx integration. Okay, after solving this integration, we get the solution of differential equation, and if the differential equation is of the form, if the differential equation is the form dx by dy plus px equals to q, then it is another form of same linear differential equation, but here p is a function of y, or it becomes a constant, and q is a function of y. Then here the integrating factor must be equals to e to the power py dy, and the solution is exactly same what we have done here, and we get the result. If the differential equation is in the form of dx by dy, then we should do this, and otherwise if the differential equation is in the form of dy by dx, then we should do integrating factor as e to the power px dx and then solve it. And now let us take an example. Let us take an example that x cube minus x dy by dx minus 3x square minus 1 y equals to x fifth minus 2x cube plus x. Okay, then if we take this, then what we will do, we have to convert this equation to this type of equation as in general form. So what we can do, we can divide the x cube minus x in each term. So dy by dx minus 3x square minus 1 by x cube minus x y x fifth minus 3x x fifth minus 2x cube plus x by x cube minus x. Okay, so this is in linear differential equation where px is nothing but that minus 3x square minus 1 by x cube minus x. So integrating factor equals to e to the power exponential px dx integration. So exponential of minus 3x square minus 1 x cube minus x dx integration. So this becomes exponential minus, and it becomes ln x cube minus x. So it becomes 1 by x cube minus x. So multiply integrating factor on both side of the equation, this equation, then what we will get? We will get 1 by x cube minus x into y equals to x cube x fifth minus 2x cube plus x cube minus x into x cube minus x dx whole integration. Okay, then what we will get if we integrate it, then it becomes y by x cube minus x equals to x. If we take x common out, then it becomes x into x square minus 1 whole square divided by x into x square minus 1 to x into x square minus 1, and here dx and integral. X cancel out, and there is also x square minus 1 whole to the power 2, and there is 2 term here, so it will also cancel out, and it becomes y by x cube minus x equals to 1 by x dx integration. So then it becomes y by x cube minus x equals to ln x plus c, and y equals to x cube minus x into ln x plus c x cube minus x. Okay, so this is our solution of this linear differential equation. Okay, now if the differential equation is of the form like dy by dx plus pxy equals to qx y to the power n, so is it a linear differential equation? Definitely not, because here the y term contains power n which is greater than 1, so it is not a linear differential equation. But we can solve this differential equation by converting it into a linear differential equation. So this type of equation in which contains some power of y is generally known as Bernoulli equation. Bernoulli equation, and it can be reduced to a linear differential equation. So let's see how we can do it. Let us take an example. Generally we divide y to the power n both side and taking suitable substitution, then we can solve it. Let's see in an example. Okay, let's see an example. Example is x dy by dx plus y equals to x cube y sixth, where y1 equals to 1. Some initial condition is given and the linear differential equation is given. So we have to solve this linear differential. We have to solve this differential equation. Sorry, it is not linear. So we first have to convert it into linear form, as there is a y to the power 6. So divide y to the power 6 both side, then it becomes x by y to the power 6 dy by dx plus 1 by y to the power 5 equals to x cube. So now to further we can simplify it by dividing x on both sides, then it becomes dy by dx 1 by y6 here, and here x x into y to the power 5 equals to x square. So now we have to distinguish the dy by y6 value and 1 by y to the power 5 value. We can write it as dt by dx minus 1 by 5 dt by dx plus t by x equals to x square. Okay, if this, then taking constant to x square side, then it becomes dt by dx minus 5t by x equals to minus 5x square. Okay, now this equation is in the form of linear differential equation form, as here the t contains the power 1, so it is a linear differential equation and we can solve it easily by taking integrating factor, and integrating factor equals to e to the power minus 5 by x dx integration. So it becomes e to the power minus 5, here it becomes ln x. Okay, then it equals to e to the power 5 minus 5 ln x, it becomes 1 by x to the power 5. So now we have to multiply 1 by x to the power 5 on both sides of this equation, then it becomes x to the power minus 5 into t, and it becomes minus 5x square into x to the power minus 5 dx integration, then it becomes minus 5 x to the power minus 3 dx integration, and it becomes minus 5 x to the power minus 2 divided by minus 2 plus c. Okay, then minus cancel out, and then it becomes t, then t equals to 5 by 2 x to the power minus 2 divided by x to the power minus 5. We have to divide x to the power minus 5 both sides, then here equals to c by x to the power minus 5, then it becomes 5 by 2 x to the power 3, and it becomes c x to the power 5. Now putting the t value is 1 by y to the power 5 equals to 5 by 2 x cube plus c x to the power 5, and this is our solution of the differential equation, which is not in a linear form, but we can convert it into a linear form and then solve it, and the and there is also some boundary condition is given that y1 equals to 1. So it means that when x equals to 1, then y equals to 1. So putting this then in this equation, then we get 1 equals to 5 by 2 x cube means 1 cube equals to 1 plus c. So c equals to 1 minus 5 by 2 is nothing but that minus 3 by 2. So we have to put the value of c, so we get 1 by y to the power 5 equals to 5 by 2 x cube minus 3 by 2 x fifth, and this is the solution of the linear of the differential equation, which is not linear, or we can say that the Bernoulli equation. Next we should see exact and non-exact differential equation and solving of that type of differential equation.